Hi, this project is related to basically enhanced 7-level single-phase H-bridge multi-level inverter with nearest level control for grid-connected photovoltaic system. This project is built in basically the Plex software as well as in MATLAB. So the thing is that in this project we are just calculating and investigates the grid-tied photovoltaic system interfaced using the multi-level inverter, okay, for the controlled voltage injection to the grid supply. So I have used the 7 level of cascaded H bridge, which is used for the DC input source voltage with the solar voltage, uh, whose the nonlinear characteristics of are modeled using 5 unknown parameters. So this system is operated at the output side is 220 volt, which is with the 50 hertz frequency. So in the last part, we just overcome the harmonics of sinusoidal waves, and we also overcome the harmonics in terms of voltage, in terms of current of the grid system basically. So this is the introduction in which explains the complete structure of the system, like how inverter circuit is connected with DC power supplies, and then how it transfer bridge circuit is converted from DC to AC. Then it uses the transformer system. Transformer boost up buck boost converter is used to boost up the voltage level, and then we provide it to the grid as well. So total harmonic distortion means this formula we are using the total harmonic distortion. So next part is basically we are calculating the 7 level multi inverter circuit with the electromechanical switch by CJ, which is basically this one. Okay, so it means that this is the CJ switch basically, in which VCC applied and then 7 level multi inverter. Okay, 1 2 3 4 5 6 and 7. Okay, 6 and 7 level. So basically this contains the 7 level multi inverter. Okay, so see, this is a square wave and the fundamental sine wave and the third and fifth harmonic signal. Okay, so this uses the H bridge as well. Yes, this is the H bridge which converts the DC to AC. Okay, so in the problem statement I have also written the complete problem statement for the multi-layer single phase H bridge cascaded inverter. So methodology is written here. Literature review, I have detailed entered the complete literature review in which we are using the grid, meter, fuse box, battery, DC inverter, DC AC inverter, and modules of DC. Okay, so everything is explained in this section. Okay, so the methodology approach is basically we are using the research approach, which contains the complete Plex software module, including the solar PV module, H-bridge multi-level inverter, grid, and the nearest level control system as well. Okay, this is a block diagram I have entered in it, and the next part is basically this is a single diode model which depict the 5 parameters of the solar PV. And next, all the equations are given. This is basically the steps involved in 3D look table construction. Okay, PV panel dataset, estimation of 5 unknown modeling parameters, and everything. Okay, all the equations and the systems are mentioned in it. So you just read it and then you will understand the complete. This is basically the non-linear module for the PV system, which contains a 65-watt photovoltaic array calculated. Okay, so multi-level inverter topology is there. This is a 7 level multi-level uh, inverter is H bridge with cascaded H bridge inverter. Okay, 1 2 3 4 5 6 and 7. Basically 1, 2, 3, 4, 5, and 6. Basically, it uses the 3H bridge. This is basically 3H bridge, but it provides us 7 levels. Okay. See, these are the 7 levels tables are added in. Okay, and I'm sorry. Okay, the next part is basically nearest level modulation control strategy, which uses the modulation index using the reference voltage and the DC voltage. Okay, so these are the topology used. We are using in it, and yes, this is a block diagram of nearest level control system in which sinusoidal is the reference voltage and remaining is basically the DC voltage is basically provides the level control voltage. Yes, the table is also given in it, and this is the plex simulation. Okay, see, MPPT controller is used. This is the input PV system, then it calculates the voltage, current, and then it H bridge. It uses the circuits and then transformer, and then it basically this is a boost converter use, and then transformer converts to the H bridge, and H bridge converts to the again AC system, and AC system also provides the to the grid. This is a grid basically. Okay, the plant simulation is here. This is a complete simulation for positive and negative electrodes of the control level control, and this is the nearest level control, second level simulation schematic, and this one is basically the nearest level control for level 1 simulations, and this is basically the PV connected maximum power point tracking based circuit simulation. And in the result section we are we are calculating the output voltage, output current, and the output power basically. Okay, so this is a voltage, current, power according to PV modules. This contains the voltage, power, current provided to the grid connected. And waveforms are this is a PWM waveform for the MPPT, and everything contains in it. Okay, IGBT gate levels and outputs, and then conclusion added and references. Okay, so the next part is basically let me just show you. These are the project files in which I have just takes the complete output power diagrams. Okay, these are the complete input output system which contains the power level, circuit diagram, and everything. Okay, and yes, this is the complete circuit diagram also included in it. Okay, if you need to ask anything, you can just call me and you just ask me the questions. I will answer your questions. Okay, thank you.